Welcome back to Inverse Functions, Part 3. We're going to take a look at some examples, probably similar to the homework that you'll see. The first one is, remember that sine of some angle, we'll call it theta, equals some number. Okay, and we don't know what that number is, but let's say we want to find theta. Well, sine of theta is equal to that number. And so if we want to just get the theta isolated, remember we can impose sine inverse of sine of theta. And on the right-hand side of this equation, we can stick a sine inverse over here as well on the right side. Now, do you see how we now can cancel the sine inverse and sine and get a theta equals something? Now remember, we are looking for an angle. This will give us an angle. This is very, very critical to keep in mind when we're doing this. The other thing to remember is that in addition to the range of sine inverse is negative pi over 2 to pi over 2, the other thing we have to keep in mind is the domain of sine inverse is negative 1 to 1. So let's take a look at this first exercise. We have sine inverse of negative root 2 over 2. Now, as I said before, if we're looking for the sine inverse of some number, we are actually trying to solve for an angle. And it's going to be probably fairly helpful for you to do this in degree mode. We're trying to figure out what the angle would be. So let's write this as sine inverse of sine of theta equals something we don't know. Now, what angle will give you a negative root 2 over 2? I know that this has been replaced with a number, so what sine of an angle will give us a negative root 2 over 2? I happen to know that sine of 45 degrees will give me a positive root 2 over 2, but I have a negative root 2 over 2. So I'm going to make this a negative 45 degrees. Now, the sine inverse of sine of negative 45 degrees is going to be negative 45 degrees. You can certainly do this in your calculator, but it's important to keep track of what you're looking for. This gives us an angle, not a length. Before we take a look at the next example, let's just review what arcsine means. The arcsine function is the inverse of the sine function, and it returns the angle whose sine is a given number. Now I'm going to try and explain that in sine to the negative 1, or arcsine of 0.75. Now, remember that if you want an angle, you can write this as sine of theta equals 0.75. Now that's what it means when it says it returns the angle whose sine is a given number. Therefore, if I want to get the theta all by itself, then I have to undo the sine function so that I can release the theta inside. So I would say arcsine of sine of theta, but whatever I do to one side, I have to do to the other. And that undoes the sine function, and I'm left with just the theta. And I can calculate sine inverse of 0.75. Since this is an angle and it doesn't have degrees in it, I need to think about whether this should be in radians or degrees. I'm going to use degrees because we just tend to be a little more familiar with that, but you could easily do it in radians as well. So I have my calculator here. I'm going to mode and making sure that I'm in degrees, and then finding the arcsine, blue button, second arcsine of 0.75. Now remember, sine of theta equals a length, so the angle we're finding is going to be in degrees, and it's 48.59 degrees. So the angle, 48.59 degrees, gives you an output of 0.75 as a length in the y direction. Now let's look at sine inverse, or arcsine, of 6/5. Hopefully this should be giving you a little red flag, because this is not in the domain. Does not exist. Remember, the domain is from -1 to 1 for arcsine. Next, we have sine inverse, or arcsine, of sine of pi/6. Well, remember that arcsine of sine gives us an angle. So this is just pi/6. Clearly this is in radians, so we'll go ahead and say this is pi/6 radians. Next, we have sine inverse of sine of 5 pi/6. 5 pi/6 is not between -pi/2 and pi/2. So what I've sketched here is approximately where 5 pi/6 would hit. So the reference angle is equal to pi/6, which is in the domain. So we can say sine inverse of sine of pi/6 is equivalent in height to 5 pi/6, but now it is in the domain. See how I'm referencing the height of 5 pi/6 to define the reference angle's height at pi/6, which is in the domain, and we are able to then calculate that the angle we're finding is pi/6. You can check this with your calculator by substituting, but first making sure you're in radians, sine inverse of sine of 5 pi/6, and it actually auto converts it to pi, the value in decimals of pi/6, which is approximately 0.52 something. And it's really important for you to understand how to tell the difference between finding an angle and finding a length. We'll take the same approach to find the inverse functions of the other trigonometric functions. So this is something that you absolutely have to practice.